Graphical Determination of Laws. The table below shows how the height S meters of an object thrown vertically upwards varies with the time t seconds. The relationship between S and t is represented by the equation S is equal to negative at squared plus pt plus 10, where a and b are constants. A1. Using the information in the table, determine the values of a and b. 2. Complete the table. B1. Draw a graph to represent the relationship between S and t. Using the graph, determine the velocity of the object when t is equal to 5 seconds. The data given below represents the average monthly expenditure E in Kenya pounds on food in a certain village. The expenditure varies with the number of dependents D in the family. On the grid provided, plot E against D and draw the line of the best fit. B. Find the gradient and the E-intercept of the graph. C. Write down an equation connecting E and D. D. Estimate the cost of feeding a family with 9 dependents. Data collected from an experiment involving two variables x and y was recorded as shown in the table below. The variables are known to satisfy a relationship of the form y is equal to ax cubed plus b, where a and b are constants. From each value of x in the table below, write down the value of x cubed. B1. By drawing a suitable line graph, estimate the values of a and b. 2. Write down the relationship connecting y and x. Two variables r and v are known to satisfy a relationship r is equal to k v raised to the power of n, where k and n are constants. The table below shows data collected from an experiment involving two variables r and v. Complete the table of log v and log r shown below, giving the values to two decimal places. B. On the grid provided, draw a suitable straight line graph to represent the relationship r is equal to k v raised to the power of n. C. Find 1. The gradient of the line. 2. A relationship connecting r and v. Two quantities p and r are connected by the equation p is equal to k r raised to the power of n. The table of values p and r is given below. A. State a linear equation connecting p and r. B. Using the scale 2 cm to represent 0.1 units on both axes. Draw a suitable line graph on the grid provided. Hence, estimate the values of k and n. The table below shows the values of the length x in meters of a pendulum and the corresponding values of the time t in seconds of its oscillations obtained in an experiment. Construct a table. A. Construct a table of values of log x and corresponding values of log t, correcting each value to two decimal places. B. Given that the relationship between the values of log x and log t approximate to linear law of the form log t is equal to b log x plus log n, where a and b are constants. 1. Use the axes on the grid provided to draw the line of best fit for the graph of log t against log x. 2. Use the graph to estimate the values of a and b. C. Find to two decimal places the length of the pendulum whose period is 1 second. A solution was gently heated. Its temperature readings taken at intervals of 1 minute and recorded as shown in the table below. Draw the time temperature graph on the grid provided. Use the graph to find the average rate of change in temperature between T is equals to 1.8 and T is equals to 3.4. Amina carried out an experiment to determine the average volume of a ball bearing. She started by submerging 3 ball bearings in water contained in a measuring cylinder. She then added 1 ball at a time into the cylinder until the balls were 9. The corresponding readings were recorded as shown in the table below. A1. On the grid provided, plot XY, where X is the number of the ball bearings and Y is the corresponding measuring cylinder reading. 2. Use the plotted points to draw the line of base fit. B. Use the line of the base fit to determine 1. The average volume of a ball bearing. 2. The equation of the line. C. Using the equation of the line in B2 above, determine the volume of water in the cylinder. The graph below shows the rate of cooling of a liquid with respect to time. Determine the average rate of cooling of the liquid between the 2nd and the 11th minute. In an experiment involving 2 variables T and R, the following results were obtained. On the grid, draw the line of the base fit for the data, and variables R and T are connected by the equation R is equals to AT plus K, where A and K are constants. Determine 1. The value of A and K. 2. The equation of the line of the base fit. 3. The value of T when R is equals to 0. The table below represents a relationship between 2 variables X and Y. A. On the grid provided, draw the line of base fit. B. Use the graph to find the value of Y when X is equals to 0. The length of a shadow of a mast was measured at intervals of 1 hour and recorded as shown in the table below. On the grid provided, draw the graph of length against time. 2. Determine the rate of change of the shadow length at T is equals to 2. In an experiment involving 2 variables, time T, hours, and height h centimeter, the following results were obtained. On the grid provided, plot TH, where T is the time and H is the height. Use the plotted points to find line of base fit for the data and hence determine the rate of change of height with time. The table below shows the value of T and the corresponding values of H for a given relation. On the grid provided, draw a graph to represent the information on the given table. Use the graph to determine correct to 1 decimal place the rate of change of H at T is equals to 3. The population growth of a colony of bacteria was recorded at intervals of 5 seconds as shown in the table below. A. On the grid provided, draw a graph of the population against time. B. Use the graph to determine correct to 2 decimal places the average rate of change of population of bacteria between T is equals to 5 seconds and T is equals to 20 seconds. A stone was thrown upwards from a point 8 meters above the ground. The following graph shows the height h meters of the stone above the ground at the time t seconds in interval 0 and 4. Determine the rate of change of h at t is equals to 2 seconds.